Hello, and welcome to today's webinar. My name is Michael Kramer, and I am presenting today on behalf of Perry Johnson Laboratory Accreditation. Excuse me. And as you can see, today's topic we're going to go over the requirements in section 6.4 of ISO IEC 17025 2017, which is the section on equipment. As always, this webinar is being recorded. You can go back and re-listen to it or through the PJLA website. You can also go through the website and request the slides. You can also go back and listen to an array of past webinars that we have presented to you over the last few years. Currently, I sure hope everybody can hear me. You're muted. However, there is a question tab on your screen. During the course of this presentation, if a question arises, feel free to type it in there. And at the conclusion of the presentation, I will review the questions. Please keep the questions regarding today's topic, which is equipment and the requirements within section 6.4. So regardless of what is required within 17025, if you are a calibration, testing, sampling organization, you want to, of course, assure that your equipment is properly maintained, which is a prerequisite for ongoing accuracy of your testing calibration results. So this section here, section 6.4, deals with the capabilities and quality of the equipment. Of course, the whole idea is to make sure that equipment is suitable for performing the selected testing calibration and is well characterized, calibrated, and maintained. So looking at the requirements here under section 6.4, of course, you have to have the right tools to do the job, which is basically the gist of clause 6.4.1. And having access. You shall have access to equipment. So when you think of equipment, it's of course, it's equipment used directly to perform the calibration. However, this section does expand on the definition of equipment to include measuring equipment, software, measurement standards, reference material, reference data, reagents, consumers, or auxiliary apparatus. So 6.4.1 regarding equipment requires that you have access to the equipment which is required for the correct performance of laboratory activities, which could influence the results. There are some notes added under section 6.4.1, clarifying reference materials, which is ISO 17034. Also references to ISO Guide 33 as a resource for selecting reference materials for those testing folks that may utilize testing in your testing activities. 6.4.2, in cases where the lab uses equipment outside its permanent control, it shall ensure that the requirements of this equipment for this document are met. Things like accuracy, things like traceability, that's being maintained. One thing I like to bring to light here, and I do quite a few of assessments, our equipment always stays in our control. For those of you all that perhaps when you send your equipment out for calibration, if you think about it, when that equipment is being shipped out and also when it's being returned to you, there is a period where it is outside your control. So just regarding this, a check per a defined procedure should be made before the equipment goes out that would incorporate both the function and calibration of the equipment and determine if it's shown to be satisfactory upon return, i.e. some sort of checkpoint, some sort of check on the equipment where you can tell where it is returned, if something has happened, if it is deviating from what the expected results would be upon its return. Clause 643, a requirement to have a procedure. So shall is a requirement stated here. You shall have a procedure for the handling, transport, storing, and use and plain maintenance of equipment in order to ensure proper functioning and to prevent contamination or deterioration. This could be as detailed as you like. It could also reference manufacturer protocol. Or if you're one of the a facility that regularly takes your equipment, say, off the premises on site, additional procedures may be necessary to assure equipment is packed securely, transport in a manner that would maintain the integrity of their traceable calibrations. 644. The laboratory shall verify that equipment conforms to specified requirements before being placed or returned into service. So we'll look at that when equipment needs to be calibrated at next, but of course that can be utilized to verify that it conforms to specified requirements. However, perhaps you have control limits set within the standard, within your testing protocol, where you can assure that everything is remained in a state of statistical control. The equipment used for measurement shall be capable of achieving the measurement accuracy and or measurement uncertainty required to provide a valid result. So perhaps your testing protocol has specifications, requirements for the equipment you use, i.e. resolution of a balance, for example. If you're a calibrator, of course, you want to ensure that the equipment you're using is going to be of a better accuracy and higher tolerance classification than that of what you are comparing it against. So, for example, I have a tolerance table for test weights there. So you want to ensure that your equipment that you use when you're using, say, a test weight in this example, that the accuracy requirements are going to meet the need in your testing or calibration protocol. We talk about calibration. So most equipment, of course, I'm assuming that you have it calibrated prior to be putting in the service. However, it is required to be calibrated when the measurement accuracy or measurement uncertainty affects the validity of results of reported results. And it shall be calibration is required to establish metrological traceability on the reported results. So by definition, traceability all includes the measurement uncertainty. Hence, if you are needing to establish metrological traceability, of course, you want to assure that the equipment is calibrated and you have that uncertainty associated with the calibration. So notes within 17025 expand further on types of equipment having effects on the validity of the reported results. Can include those used for direct measurements. For example, a balance used to perform mass measurements or to make corrections to be measured, such as temperature measurements. Or those used to obtain measurements results calculated from multiple quantities. For example, air buoyancy, air buoyant effect, if you need to take into account various environmental effects. So it's not only just include the primary piece of equipment that's used to perform a calibration or test. It can should also expand into those auxiliary equipment that are also incorporated into the test or calibration that's being performed. So we mentioned a calibration shall be calibrated prior to be put into service if the accuracy depends on it, or if it's needed to maintain metrological traceability. 647 revolves around a calibration program, which shall be reviewed and adjusted as necessary in order to maintain confidence in the status of calibration. So calibration is not a one-time event. And risk should be considered when selecting calibration intervals. So I referenced section 710, which is the area of non-conforming work. So one thing we don't want to happen, particularly if you have a long calibration interval, is sending the equipment in for recalibration, and it happens to fall out of tolerance. Hence, section 710, non-conforming work would come into play, and an investigation would need to be done for determining how far back you would go before that equipment was determined to be within tolerance. So if you have no intermediate checks, if it's been calibrated on an annual basis, you would have to go back a year. If you're going to take a risk and do a 5-year interval with limit intermediate checks, possibility you have to go back 5 years, perhaps 5 years of recall. So calibration is not a one-time event. 648, all equipment that are required to be calibrated or has a defined period of validity shall be labeled, coded, or otherwise identified to allow the user of the equipment to readily identify the status of calibration or period of validity. So if you have an instrument, say a centrifuge, a balance, whatever it happens to be, the user should be able to determine whether or not it is in a state of calibration. Ideally, yes, it could be labeled, and that is how often I typically will see this handled. Often the calibration provider will put a label right on there, but that's not required. It just needs to be readily available. So if a user can produce that information in a relatively short period of time as to the calibration status of equipment, as long as it's readily available. There are some circumstances where labeling is not possible or reasonable. Could include if labeling would compromise the results or accuracy, i.e. putting a label on test weight, for example, is going to alter that mass value. If it's being used in harsh environment where the label would not survive, or the size of equipment is not sufficient for labeling or coding. Tiny, small thermometers, for example, think of the liquid and glass total immersion type, where if you put a label on it, you may not be able to read the display. (649) defective equipment. So if for whatever reason, if equipment has been subject to overloading, mishandling, or give questionable results, or shown to be defective, or perhaps you do have intermediate checks and find that, hey, it's outside of specified predetermined limits, it needs to be taken out of service and shall be isolated to prevent its use, or clearly labeled as being out of service until it has been verified to perform correctly. The laboratory shall examine the effects of the defects of the deviation from specified requirements and shall initiate the management of non-conforming work procedure. Again, section 710, non-conforming work. So, i.e. if equipment was being used when it was determined that it may be outside of operating outside of predefined limits of acceptance, possibility you have to implement the protocol established in section 710 there. So intermediate checks. When intermediate checks are necessary to maintain confidence in the performance of equipment, these checks shall be carried out according to a procedure. So of course, when you send your equipment out, say for calibration, and let's say you have it on an annual basis, you have a warm fuzzy feeling when it came back. Hey, it's operating. It's been calibrated. It's within where we need to keep it. Where it needs to be. Intermediate checks are used to assure that the equipment is not drifting out. Is not drifting outside of predetermined limits of acceptance. Often with you folks that are utilizing testing, they shall be carried out according to a procedure. Often you have these built in with things like blanks, spikes, known reference materials that's worked in with the testing protocol. So, ideally, if there was something drifting within the equipment, these checks would catch it, and you would know not to proceed with the test. For calibration, ideally, yes, control charts are often utilized. Say testing a balance with a known test weight prior to proceeding calibration, particularly if you are doing an on-site pipette calibration to assure that the display is indicating within predefined limits of acceptance. Again, risk can be considered when determining how often intermediate checks are needed. Example I gave of a 1-year calibration. Say you did set the protocol as a year. You have a good intermediate system of checks. If you have that intermediate check done, say, on a monthly basis, worst case scenario, as long as you have a good baseline when it came back, you run these intermediate checks. It's been within predefined limits right up until the time that you sent it off for calibration. Then perhaps just would need to go back if you have the records to support it. Go back to the last time the intermediate check, determine it within prescribed limits. If you had no intermediate checks in place, then you would have no choice but go back the entire year. Since the last time you knew the device was operating within acceptable limits. Correction factors, 6.4.11. So when the calibration and reference material data included in reference values or correction factors, the laboratory shall ensure the reference values and correction factors are updated and implemented as appropriate to meet specified requirements. So what we're referring to here is, again, calibration. You could send an instrument out for calibration. Often you should see the data there, where have some examples there at the bottom. Perhaps that's a temperature standard. You have a certain tolerance that you base the pass-fail on. However, very seldom are you going to see that equipment being directly on nominal, that there's normally a deviation from nominal that's specified within the calibration report. So the correction factor is when you apply that deviation. Things that may need to be updated perhaps could be data sheets where the correction factors are captured, or more likely software. If you are utilizing correction factor, have to assure the correction factor are being updated in the software appropriately. So for example, if this particular here where we have a correction, say it's degrees Celsius. So when your thermometer is reading 110 degrees C, it's stating it's 110 degrees C. Now it's actually 109.3. So you would apply a minus 0.3 degrees as a correction factor. If, of course, you are utilizing correction factors. 6412, the laboratory shall take practical measures to prevent unintended adjustment of equipment from invalidating results. So again, with calibration, your calibrator, often when the equipment is out of tolerance, they can perhaps break a seal, go inside, adjust the instrument, and bring it to within applicable tolerances. So you want to assure once the equipment is returned that practical measures are in place to intend unintended adjustments, or in other words, hey, not to break any seal, which if broken, the integrity of the traceability provided with that piece of equipment may come into question. All right, the records. So with equipment, you are required, of course, to maintain records, which can influence laboratory activities. And under 6413, we have a listing of records where appropriate shall be maintained. And this, of course, includes the identity of equipment, including any software and firmware, manufacturer's name, type information, serial number, evidence of verification that the equipment conforms with specified requirements. Location, that may or may not be applicable if all the equipment is always in the same place, as would be an NA. Perhaps you have technicians that are assigned different equipment that actually go on site to perform the testing or calibration, and that would be applicable. Of course, you want to keep the calibration results, those reports, the calibration dates, results, any adjustments that assuring that the equipment was met the accepted criteria, and the due date of the next calibrations. We have a calibration program recall, so we want to know when, keep a record of when the next time the equipment would be due for calibration. Same with the reference material. Results from the reference material reports, accepted criteria, relevant dates, and period of validity. Once you break a seal on reference material, often that starts the clock running on that period that of validity that reference material can be used for. Any maintenance plan or maintenance carried out to date where relevant to the performance of equipment, and details of any damage, malfunctions, modifications, or repair of the equipment. So these records need to be maintained and should be produced as requested. They don't have to all be maintained in one location. So just as long as they're maintained, all those that are applicable. So we have now gone through the entire section 6.4, which is actually equipment. So bear in mind here, what I mentioned at the beginning, that there is a no problem. You are able to type in questions, so that's we've hit that protocol. First thing I have here is there an echo? So I hope folks reading here. I have a couple comments about the echo, and about the third one down. I have fixed it. Thank you. So hopefully that was on your end and not my end. So hopefully the echo will was not on my end. Yes, question asked, can get a recording of today's webinar? Yes, go to pjlabs.com, and then we have a webinar tab there. So you can go there and you can select today's webinar there and re-listen to it. And like I mentioned at the beginning of the webinar, we have a history of past webinars there, so there could be other topics that interest you. Here's one here. How do we determine what type of calibration service is needed? 17025 accredited calibration always required. NIST traceable Z540 sufficient to satisfy this clause. Again, I want to resort to traceability. So, i.e., if traceability is needed, then I call it a slam dunk. If you go to a source that is accredited through an ILAC MRA, such as Perry Johnson Laboratory Accreditation, to perform the calibration, you get the accredited type calibration with calibration results. I can refer to that as a slam dunk. That would be considered a traceable measurement. So if traceability is needed, then hey, if you go to a accredited source and get the proper calibration, that would meet the bill. Meet the requirement. If you happen to go to an unaccredited provider and don't want to go too much off base here, we do have protocol, and you can review this in our PL2 on traceability for non-accredited sources. The thing though with that is you have some additional hoops to jump through. So we talk about in PL2 the 7 elements of traceability. So typically, I as calibration program manager, I get these requests and I look for additional objective evidence. Like I mentioned, measurements would not be considered traceable without a measurement uncertainty. Would have to take it a little further, look at the equipment that was used to calibrate your equipment, and hopefully to have some sort of internal measurement assurance program in place. So depends on what your requirement is. If you are required to have traceability, or if uncertainty, if it's a significant contributor to your testing or calibration results, then chances are you need to go to a 170 provider. And like I mentioned, hey, you could still be not accredited and get traceable results. However, there's additional hoops that would need to be jumped through. All right. Will I be sending the slideshow to us? Again, go to our website under the webinar tab. You'll see an area where you can request just the slide presentations. Click on that link, and you would be able to just get the presentation, and then you can use it. You can provide your own training to your folks, however you like to utilize it. Next one is regarding calibration intervals in 647. Like I said, calibration is not a one-time thing. Can I only assign monthly and year for the calibration of my standard equipment, or does it need to be exactly day, month, and year? Standard really doesn't have a requirement concerning that. You need to establish a program. So I would say if you are consistent with when you establish a month and a year that you're referring to the last day of the month, you established a program, then I would say that would be sufficient. For calibration due dates, again, does it need to be done on the exact due date based on defined frequency, quarterly, annually? What if the exact due date is not available for a third party or in-house schedule? If annually, can the lab define it as 12, 13 months? Again, you define the calibration schedule. You would establish the program. And like I mentioned, calibration is not a one-time thing, and risk would need to be taken into consideration. So if you have something set at a month, or excuse me, on an annual basis. I would recommend, if you felt the need and you considered risk where you need to extend it for another, say, a month based on the availability of your particular supplier, that you document that, hey, you've extended the calibration interval, considered the risk, i.e. that it would have gone out of tolerance, and document that. So yes, you can fluctuate with your calibration schedule. I've seen it before when a lab has closed down for whatever reason, loss of personnel. Hey, it's up to you. Hey, if you want to extend the calibration interval, you would have to consider the risk. And then also, when I say risk, hey, if it's going to go another whole year, for example, hey, that's a pretty big risk because it could go out of tolerance, and then you were using a out of tolerance piece of equipment on your customer results. How long do calibration and maintenance records need to be kept? I would say there is no requirement specifying that in 17025. In records, you have to establish retention time. As far as Perry Johnson Laboratory accreditation is concerned, our reaccreditation cycle is every 2 years. So just for those of you that are accredited with us, say, hey, you need to at least keep them 2 years, just for that. But there is nothing in the standard that says you shall maintain these records for X amount of years. Someone asked about guide 33. So yeah, that's an ISO guide. So go to iso.org would be my first go-to reference for that, iso.org. This here is referring to breaking the calibration seal. If the calibration, in case of breaking the calibration seal, to try to adjust the results, wouldn't the results already be rendered invalid as soon as you break the seal? I would say yes. Once you break that seal, then the integrity of that traceable calibration would come under question. Do we need to have a certificate of calibration from a third party before we can officially use the equipment balance? I'm assuming you're referring to your calibration report. Again, standard does not address that. I would say, hey, you may not be able to get the calibration report directly. Then you probably want to get assurance that when the calibrator leaves, that it's within tolerance. And but I don't see any problem with using it prior to getting a report. Just as long as you know that the as left data was within tolerance. Of course, you want to look at that as found data as soon as possible to assure it was in tolerance when they calibrated it, because again, then you would have to follow protocol in non-conforming work under 710. We anticipate moving the lab the next few months beyond IQ. IOIQ does ISO specify other measures to ensure calibration, etc. Not directly. If you move, I know with speaking on behalf of PJLA, one thing we need to do if you move, we need to just do a assessment of the section on facilities. So I'm not sure, what your test is, but perhaps you need to maintain temperature, humidity controls, vibrations, any sort of requirement as far as facilities within your testing protocol would need to be met. And those are folks that are accredited with us. We need to be informed of that, particularly if we're going to change your scope of accreditation to reference a different location, because technically once you move, that old location is not under your scope anymore. So you need to let us know. 17025 does not address that specifically, regarding moving. You just have to assure that even in your testing in the in the facilities section, you have to document any sort of environmental limitations which you need to operate under. So when I say that, say you're doing dimensional calibrations, and you have a temperature control, say 20 degrees C plus or minus 1 degree C, if that's established in your calibration protocol, then hey, you have to assure that's being met in your new facilities. I would suggest you assure that before you move into the facility, and then inform us. But 17025 does not directly address that. Just want to assure that the environment don't adversely affect the testing or calibration results that you do. Are there a standard classification for weights for calibrating analytical balances? What comes to mind there is ASTM. I see that utilized mostly in the US. It takes them from class 1 through class 7. So you might want to check the ASTM E617 is the standard there. And it lists the nominal amount of weights in the various allowable tolerances there. Okay, good questions there. I appreciate everybody chiming in there and giving me some good feedback here on reading as well. Appreciate y'all listening. Before we move on, I just want to just give you guys a heads up here, particularly those of you all that are testing organizations. We have a webinar coming up on October 31st. So we have revised PL4, which used to be my domain as Calibration Program Manager. It was Scopes of Accreditation for Calibration. Effective November 1st, it's going to be for all programs. So one thing that we're implementing is the concept of flexible scopes in testing. Labs, RMPs, and proficiency testing providers. So this is actually next week. Happy Halloween, October 31st, 1 o'clock. Matt Sika, Technical Program Manager, will be presenting. So those folks, particularly testing, you heard of flexible scopes. Well, hey, we're implementing them at PJLA. And be sure to tune in, listen to Matt next week, and he'll go over the policy on that. Thank you, everyone, and I look forward to presenting to you folks again real soon.